Now we get even more complicated. Oh boy. So look at my algorithm and simplify each side of the equation. And it's got subtopics under that. If fractions exist. Well, they don't. So now 1b, follow appendix, order of operations, in other words, to simplify each side of the equation, and then combine like terms on each side of the equation. So, order of operations, parentheses, can't simplify inside them. Okay, exponents, multiplication, division, so I can multiply. 4 times x is 4x. I always like to say subtraction is plus the opposite, so it'll be plus a negative 7. So then I can say 4x plus positive 4 times negative 7 is a negative 28. That equals, and change this one to plus the opposite also. 5 times x is 5x plus 5 times a negative 6 is a negative 30. So 4x plus negative 28 equals 5x plus negative 30. Now, it says I need to use addition and subtraction to move all my variable terms to one side of the equation. So, in this case, I decided that I'm just going to move them to the left. In fact, I'm actually just seem to be kind of following the more structured thing. Because I've written every subtraction is addition to the opposite. Now it says use subtraction to get all variable terms to the left side of the equation. Remember that subtraction of a negative is addition of a positive. Step 3 on the structured algorithm. So, I want to get up. The x is all on the left, so I have to move this 5x. It's being added. And actually my thing just says simply just subtract it. Subtract whatever I have. So minus 5x. Do to both sides of the equal sign. 4x minus 5x is minus x. It's more negative, and it's 5 less the 4 gives me 1. So I get a negative 1x, which is just negative x, plus a negative 28 equals positive 5x minus 5x is 0 x's plus a negative 30. So equals negative 30. Now, use subtraction to get all the constants to the right side of the equation. Remember that subtraction of a negative is addition of a positive. So, if I'm subtracting a negative, so I'm going to move the 28 to the right, or out of here, so all my constants are on the right. So, subtract a negative 28 means subtracting the negative 28 means I'm adding a positive 28. Note it to both sides of the equals, both sides of the equation. So I have a minus x plus negative 28 plus positive 28 is 0 equals, so negative x equals negative 30 plus positive 28 is more negative than positive, so I have a negative. Larger digits minus smaller digits gives me a 2. So I have negative x equals negative 2. But I need to know what x itself equals. I can look at this two ways. I can say, well, negative x is, in fact, negative 1x. So, and I'm at the point...
Can I ask a question?
Yes?
Why would you not do that at the top part right here? Because that's how, I mean, how I always did it is like, you should, you know, even though the 5 is bigger than the 1.
I could have done it the other way around. I could have taken this equation when I had 4x plus negative 28 equals 5x plus negative 30, and I could have said I got more of these than that, so I'm going to put my x's on the right. I'd get the same result. I'm going to put the x's on the right. I'll subtract the 4x from both sides. We'll end up with a negative 28 equals 1x plus negative 30. So now I got x's over here. I got to get all the constants over there. So add the negative 30. So I'll subtract the negative 30, which is the same as adding a positive 30 to both sides. Will yield positive 30 plus negative 28 is a positive 2 equals x.
See, I would have had that as the x would have been 1x.
1x is fine. Yeah, 1x, but eventually I gotta get what does x equal. Well, x is 1x.
Okay, so
I don't write the 1 just because it's redundant.
Okay, my teachers back in the day, they never did that. They always left
The 1 in
and
front?
the x.
Oh, okay.
Either way, I mean, either side, whatever, if you did it to the left or just did it to the right, they always had the 1x there.
No. Eventually we actually just want to, what is x equal? But it means the same thing.
Okay.
1x is x. That's fine. I was here, I got a negative x is a negative 2. Well, I need to know what a positive x is. Positive x is the opposite of a negative x, so let me take the opposite of both sides. The opposite of a negative is a positive, the opposite of a negative is a positive, so x must equal 2. That's one way. The other way is to say, well, negative x is the same as a negative 1x, so my coefficient is negative 1, so I'll divide both sides by the negative 1. The negative 1 will divide out, I'll be left with x. Because of course negative divided by negative is positive, x divided by 1 is just x. And negative 2 divided by negative 1 is a positive 2. So we get x equals 2. And then we just want to check, because we might have made some algebraic mistakes. So we go back to our original and we say, I have 4 times, in parentheses for the x, I put the 2 in. I have minus 7 equals 5 parentheses 2 minus 6. Let's see, 2 minus 7 is minus 5. 4 times minus 5, positive times negative is negative. So I get negative 20 equals 2 minus 6 is a minus 4. 5 times minus 4, positive times negative is negative. 5 times 4 is 20. So negative 20 equals negative 20. That's true. Which means I didn't make mistakes, which means my answer actually is that x equals 2. And you thought, well, what you were doing before was wrong. Alright, one more example on this here. Okay, so looks like I was once again working with the structured algorithm. Simplify each side of the equation. That's 1. 1a, if fractions, don't have them. 1b, follow PEMDAS to simplify each side of the equation. So that tells me I got to do my distribution. So negative 3 times x is negative 3x, plus negative 3 times 5 is negative 15. And then I have the plus 2 equals 4 times x is 4x, plus 4 times 6 is 24, and I still have the minus 9. Which I kind of like to change into plus a negative 9. And I need to, 1c, combine like terms on each side of the equation. So here I have constants. Constants are like terms. So I keep my negative 3x plus, well, negative 15 plus 2, more negative than positive. And then larger digit minus smaller digit, so I get a negative 13 equals 4x, 24, actually that was easier if I left it at just minus 9, wouldn't it? 24 minus 9 is 15, 4x plus 15. Okay, so I've simplified both sides of the equation. Negative 3x plus negative 13 equals 4x plus 15. So now I need to write all subtraction addition of the opposite. Got that. And step 3, use subtraction to get all the variable terms on the left side of the equation. Well, I guess I wasn't following the structure on this because I went to the right side. So let me go back to the other side. Non-structured says use addition or subtraction to move all the variable terms to one side of the equation. Remember to do the same thing to both sides of the equation. All the variable terms to one side. So I opted in this case that I'm going to put the variables on the right. Okay, so that means I have to get the variables out of the left. I'm adding negative 3x, so I can either subtract the negative 3x, or which is the same as saying add the opposite, which is add a positive 3x. So I'm going to add positive 3x. I'm going to do the same thing to both sides with the equal sign, so add positive 3x over here. Negative 3x plus positive 3x is 0 x's. 0 plus negative 13, so I just have negative 13 equals 4x plus 3x is 7x, plus I have 15. So negative 13 equals 7x plus 15. Alright. So now the next step of the algorithm says, step 3, use addition and subtraction to move all the constants to the other side of the equation. I got all my variables on the right, so now I need to get all my constants, my plain numbers, to the left, which means I got to get this 15 out of here. It's adding a positive 15, so to do the opposite, I'll subtract the positive 15. Subtract the positive 15 from this side, I have to do the same thing over here, so I subtract the positive 15 from that side, so negative 13 minus 15 is the same as negative 13 plus a negative 15. Gives me a negative 28. 7x plus 15 minus 15 is 0. So negative 28 equals 7x. So I have a constant equals a coefficient times a variable. So now I'm ready for step 5. Use multiplication and division to remove the coefficient from the variable. So the coefficient is the number attached to the variable. I want to get the 7 away from the x. The 7 is being multiplied by the x. So the opposite of multiplication is division, so I'm going to divide both sides by 7. Negative divided by positive is a negative. 28 divided by 7 is 4. 7x divided by 7, 7's divide out, it will be 1x, which is just x. So x equals a negative 4. And then I need to plug that back into the top. And I ran out of space here, so I kind of did it short. 3 times the quantity, x is negative 4, plus the 5, plus n quantity plus 2 equals 4 times the quantity, x is negative 4, plus a 6, plus the quantity, minus 9. Let's see, negative 4 plus positive 5 is 1. Negative times positive is negative. 3 times 1 is 3, plus 2. More negative than positive, so it's negative. Larger digit minus smaller digit is to be 1. Equals 4 times negative plus positive. More positive, so we end up positive. Larger digits minus smaller digits. 6 minus 4 is 2, so I have a positive 2. 9. 4 times 2 is 8. Minus the 9, which is the same as 8 plus negative 9. More negative than positive, so I get a negative. Larger digits minus smaller digits. 9 minus 8 is 1. Negative 1 does indeed equal negative 1, so my answer of x equals negative 4 is correct. Yeah, that's a lot. That, in fact, was chapter 2, sections 1 through 3.